Math 76, Lesson 108, Transformations. So transformations are these three key words right here, found on page 521. Oops, I forgot I'm not supposed to do that. I'm supposed to, right? So we have first rotation, translation, and reflection. All right, and I'm going to give you some visual examples of what that is. But let's talk about why we would need to use transformations. The reason why we need to use transformations is this is one way that we can tell if two figures are congruent. Congruent meaning that two shapes have the exact same size and shape. So the way that we would know if two things are congruent is if one figure can be placed directly on top of the other, and it only looks like, well, sorry, it doesn't only look like, but the vertices and the sides all line up perfectly. So if you can place them directly on top of each other and they match up perfectly, they are congruent. Now let's talk about these transformation words, rotation, translation, reflection. I'm going to do that on my example paper. Right, so here, whoops, I forgot I need to zoom out. There we go. So here I've got the three words, reflection, rotation, translation, and I've also got a triangle. I know it might be a little bit difficult to see, but I've got the green side, the blue side, and the red side, so that will help us orient our triangle. So let's talk about reflection. Reflection is when we take this shape and we move it along one side, right? So the way reflection works is I can flip this triangle along the green side and reflect it that way, right? And then I can reflect it back along the green side. So if we wanted to see reflection, why didn't I pre-prep my markers? What that would look like would be the triangle being rotated along one of the sides, right? That was a terrible drawing, right? So kind of like what we just saw there. Now we could also do this along the hypotenuse. So let's say, or well, we could do this along the short side. So another way that I could do a reflection would be like this. How would I write this? Okay, you know, here, we'll do it like this. So it could be reflected that way along the short side. So if I would reflect it along the short side, it would go like that, right? So there we go. That's another way to do a reflection. And then the last way would be across the hypotenuse of the triangle, or the last shape. So if I had the hypotenuse, the red side, I'll orient it like this. So if I were to reflect it across that side, it would do that. So I take this and I just go, looks like that now. So if I were to reflect it across the hypotenuse, we now have something that looks like that. All right, does everyone see that? Okay, so that's how reflection works. With the reflection, you keep one side stationary and you reflect it like that, or like that, or like that. Kind of like if you were to picture the shape being a doorway that's opening and closing. Now let's talk about rotation. The way rotation works is you hold one vertice, right, one corner down, right, and then we can rotate the shape while keeping that one corner in the same spot. So this is rotation, right? And I can pick any corner. So I can pick this one, and that shows rotation, or I can pick the top one, pin that top corner down, and rotate like that. So the way rotation works is it looks like, oops, looks like this. All right, so that point is stationary. Oh, I meant to use a different color for rotation. It's never too late. Let's switch to blue now. Right, so rotation, right? We're keeping one vertice in a single spot and then rotating across that vertice. And I could do that across any of the three vertices. So that could be my rotation vertice, and I could rotate that way, or I could even use the other one. Now let's talk about translation. Translation, nothing stays in one spot. With translation, it's like I have the shape and I'm just sliding it left, right, up, down. That is translation. So what I'm doing right now with the shape, where I just go, that's a translation down, that's translation left, right, up, or I can just translate it like this. So the way translation works is you just picture it like this. I've got the shape, and the shape can go in any direction. And I'm just moving the entire shape. Okay? So now what we're going to be doing on our work is we're going to be looking at two shapes and figuring out which of these motions were used to move the shapes. So let's see here. I have to try to cover up these answers. I know. I will use the triangle. All right. So let's say, hold on, we got to zoom in. Let's go. We'll use this example problem right here. We're looking at triangles 1 and 2. We got to figure out what transformation was used to move triangle 1 to the position of triangle 2. If you said reflection, that's right, because if you remember, reflection is rotation across one side. So they took triangle 1. So triangle 1 looks like this, and then they flipped it down to be just like triangle 2. Okay, and then here for 2, we see translation, right? So remember, that's where we just slide things back and forth. Yeah, actually, I'm not going to give you guys all the answers to your practice problems. Let's do this. Okay, so we'll do this problem. Let's say triangles 1 and 2 are congruent. Describe the transformations necessary to position triangle 1 on triangle 2. Well, so there's a couple things. It looks like this triangle might have rotated, right? If we rotated it across that vertice, it would be the right side up. But the problem is this triangle is not in the same spot. So if I rotate it, it would be over here. So it looks like they rotated it and they translated it, so sliding it. So this one would actually have two answers, and the answers would be rotate and translate. All right? So you can have more than one answer in these problems. That's it for this lesson. If you guys have any questions, let me know on the school website, and I will see you in class.